guys, well, welcome to the Vision Lab. So we're going to put this one online too and let you answer the questions. So you should read through all the introductory information from your lab manual. Again, read over all that first, have it out in front of you, be prepared. And then you obviously have to answer all the questions on the worksheet, okay? And there are some questions on the worksheet that are not necessarily discussed in the lab manual, like what rods and cones are and the differences, which you guys can look those up obviously in your book or even on the internet. I don't care, just as long as you guys know the difference. There's another question. It's question 2 on your worksheet. It asks about what part of the brain receives images from the left visual field, and you have to find an image on the internet, which I brought one up here that you guys can see, and it asks for you to try to interpret it. So this is where it's kind of quirky, okay? And you guys can look at other images online if you like, but look at the colors. We have purple and green, okay? So it's like this is like a double whammy, okay? You guys probably have heard that in other classes, etc., that the right side of the brain receives images from the left side, vice versa. Well, that's the case. So here we have the green, okay? So look at the green. It's like the green is the right side of each eye. So if I look at each individual eye, the right side of each eye is green, okay? And that is actually receiving the left visual field, the green. So left visual field is up there in green. It's received by the right sides of each eye, the green, and then you got to follow the nerve pathways, the axons, which would then obviously crisscross right here. But not everything gets crisscrossed. Some of it does, some of it doesn't, depending on the right and left eye. That's where you want to look at the picture. So we're going to go with the green and follow it all the way down here. And you guys can see that the left visual field is actually processed by the right occipital lobe, right? Occipital is for vision of the brain. So the visual cortex, that's right here. That would be the visual cortex, but it's the right side. So the left visual field follow down. So it's the left visual field. It's actually being seen by the right side of each eye, but then it gets processed also by the right side. And then the purple obviously would be the opposite. Okay, so use images like this for answering that question and the interpretation there, etc. All right, then there's some other areas that you guys need to go over in the lab. The next part is actually using this model right here. This is called the Ingersoll eye model, and what you're going to do, or I'm going to do this for you, okay? It actually says to start out with, make sure everything's working. Oh, I guess I gotta make sure it's plugged in. Sorry about that, guys. All right, so this is kind of like a mini eye. Okay, and there's a star on here. Well, here's your eye. This is like your nose right here where your glasses go. See my glasses, okay? This clear part would be like your cornea. The light's gonna shine in, and then that light is gonna shine back here inside of here, and it's going to be projected back here on the back part of your eye. The back part of your eye, guys, is called the retina, and this spot right here with the dots, that is called your focal point, or the fovea centralis, and that is where you have the highest concentrations of cones at, okay? Now, I'm going to take my star, and I'm going to place it this distance apart, and you guys can see that the star is now projected inside here into the focal point. You can see it's kind of bright. Now, if I take the +7 lens, now there's different curvature. I want to talk about that real quick. Let me have your attention up here. If you have a curved lens that goes in like this, that means it is concave. If you have the opposite, where it curves out, it's convex. Also, this is a negative curvature. This is a positive curvature. So if any of you guys have various eye problems, again, you might hear your doctor talking about the different curvature of your lenses depending on if you're nearsighted versus farsighted. And that reminds me, let me grab my book real quick. Give me 1 sec. You can just sit tight for 1 sec. In your book on page, I believe it's 175. I hope I'm right. I should have got this earlier. Yes, I'm right. I'm good. Page 175. This is what you guys want to pay attention to, okay? So this is kind of like your little mini eye, okay? So you're going to have your eyeball, and then the light is going to converge in and be corrected back here and converged into that point. and that is called your focal point or foveal centralis, or the little dotted area I showed you on the model a little bit ago. In this case, we have somebody that has myopia and they are nearsighted, okay? They have an elongated eyeball, so we have a problem, okay? So people that are nearsighted see better near than they do far, and their eyesight is corrected with a negative or a concave lens. Here's the opposite for some people that actually have hyperopia or are farsighted. They have a short eyeball, as you guys can see, and the rays are converged back here behind the actual retina on where it should be. See the, where it should be at. So in this case, these people have a condition called hyperopia or farsighted, and it's corrected with a corrected lens, which again in this case would be a convex, a positive curvature. Then there's some people that have misshaped eyes and or lenses, and this is where you have to have a very unique type of lens that's miscurved, and these people have what's called as astigmatism. That's where the lens, again the yellow circle right here, is misshaped and at different angles, and this is where the doctor has to find out the exact curvature, and it uses an uneven lens to fix the problem. So we're going to use this with this little model, okay? So back to the little model. So right now we have it set up and you really can't tell anything, but remember you have a lens in your eye, right? And in the directions it tells you to put the +7 back here in the rearmost spot, and oh my goodness, can you guys see the star? If I take that +7 out, it's blurry, but if I put a +7 curvature in there, that's like the lens that you have in your eye. We all have a lens in our eye. You can see the star nice and pretty. So that's how it works. But guess what? Your eye is actually filled with a gelatinous material. So I'm going to go take this and fill this up with water real quick. So give me 1 sec while I fill this up with water. Now remember, I left the +7 lens in there. And what do you think is going to happen, guys, as far as the +7? Do you think that's going to be enough curvature after I put the water in here? I think that's going to be enough to see that nice pretty star like you saw?
Maybe not.
Maybe not. I think the curvature is going to need to be readjusted. Oh no, what happened to my star in my focal point right there in the dotted area? It's blurry, right? Now, the +7's still in there, but even when I take the +7 out, it even became more blurry. Now your eye actually has a fairly large curvature structure, and what are these yellow circles in this picture called? These yellow circles are your lens, and even when you look at this picture over here, again, all of your guys' eyes have a lens in it, and we're going to use this one now. The other one was a +7, this one's a +20. Do you think that's going to allow the star to be seen on the back of the retina? Again, the retina, again, the rearmost spot. Okay, now watch, I'm going to put the retina, or sorry, no, I'm going to put the lens into the eye, because we all have a lens, unless you've had cataracts. And, oh, do we have a star now?
Oh, yeah.
Oh, it's perfect, right. So everything's perfect. That's in a perfect world, okay? So everything looks good. All right, the next thing we're going to do is we're going to demonstrate the effect of how the iris works and the pupil, okay? So this is actually the pupil. Now the pupil is actually a center hole in your eye. You guys know what the pupil is, against the dark hole in your eye. It's actually not a structure, it's just a hole that lets light in. And again, that's kind of like the light shining through my model right here, through the cornea, etc. But guess what? Let's say we're driving down the road, and let's say this is a really, really bright light, and somebody has their bright lights on, and you're like, oh, I can't see. So guess what? Your iris is actually going to constrict, and it's going to become smaller to make the pupil smaller, and that way it's going to allow less light into your eye, not to hurt, so your eye doesn't get hurt, okay? So what I'm going to do is I'm going to put this in the water and pretend it's like your real iris, and we're going to watch what happens to my nice pretty star. Is it as bright and as showy and as blunt as it was earlier? No, it's actually, it's more defined, it's not as bright, so this is a protector for your eye, it's for protection. So that's actually how the iris works. Again, those muscles in the iris, again, you have two sets in there that are controlled by your sympathetic nervous system. Again, it's the pupillary reflex that we talked about, the pupillary reflex. All right, the next thing we're going to do is demonstrate somebody with myopia. So somebody that's myopia or nearsighted, their eye is usually elongated. So watch what I'm gonna do, guys. I'm gonna move the retina, that's this, back to the rearmost spot, and I'm gonna have an oblong or an oval shaped retina, as you guys can see here. And oh no, what happened to my star? Can you still see my star, or did it get blurry?
It got blurry.
It got blurry, right? So when you look at my picture in my book, here's myopia or nearsighted. It's corrected with a negative or a concave lens. So in your directions, it asks you to find +2. It asks you to find +2, which I'm finding that one right now. Okay, if I can find it. So here's the last one. So I got my +2 lens and I got my -175 lens. Which one do you guys think is going to fix the problem when I put the lens on the nose of the model? The concave or the negative, right? So I grabbed actually the right one. So watch what happens, guys. So some of you guys probably have this eye condition. Oh, can you see the star now? Perfect.
Yeah.
Yeah, but again, if I take it off, well, you need your glasses on. There you go. Okay, so that's somebody that has myopia or they're nearsighted. These people see better near than they do far. Okay, so if you're sitting in a classroom, you could see your notes sitting in front of you at your desk, but you couldn't see the PowerPoint like it's sitting at your desk. You wouldn't be able to see far away, but you could see stuff close up. Now let's demonstrate farsighted or hyperopia. So I'm going to move this up to the very front spot, because people that are farsighted or hyperopia have a short eyeball. Uh-oh, what happened to my pretty star? It's gone now, right? So that's this one right here. So which lens do you think is going to fix the problem? Which glasses? Positive or negative?
Positive.
Positive, the +2. Let's see where that one's at. What did I do with that one? Oh yeah, here, right here. So let's put that one on there. Let's see if that one fixes the problem. Oh, yep, fixes the problem. You got a nice, pretty little star there. Now remember though, your eye doctor has to figure all this out precisely. That's where the eye doctor, when you go to your eye doctor, he's like 1 or 2, 3 or 4 as he's, using the various instruments to find out which lens works best with your eye conditions. Again, that's where the doctor has to have, the exact combinations. And again, my little boy's got some eye problems, and when we go to see his eye doctor, and it's a specialist, a special optometrist, he's got every bit of probably 500 of these out there for you to try, or to figure out where the problem's at, to find the best glasses, then in turn if you got contacts too, to figure all that out. So it's a very exact, precise science to get everything to be mapped out correctly to be able to see perfectly. So if you got perfect 20/20 vision, be thankful. So that's this part. That's the what we just did. We just did farsighted or hyperopia. Now the next part asks you to represent somebody with astigmatism. Now somebody with astigmatism, they have a misshaped, usually lens in this case. And what you to do is put the lens. Oh, we got to put this back in the normal spot, because people with astigmatism, they have a normal shaped eye, but the lens, again, this part is what's wrong. Okay, so I'm going to remove the stuff from the previous experiment. Okay, so follow the directions, and now we're back to our nice, pretty normal eye. So astigmatism says move the retina back to the normal position. I did that. It says place the cylindrical lens -5.5. Let me find that one real quick. Okay, you need to place this one in the slot just behind the cornea. Note that only part of the pattern is now in focus due to the unequal curvature of the eye's refractive abilities. Now look at this real close. This -5.5, it's misshaped. What I'm going to do is pretend that this is part of your lens, and I'm going to put it in the eye in the water, and watch. Only a section of the star is going to be visible. See how some of it's kind of blurry and some of it still looks fine? Yeah, so again, when somebody has astigmatism, their lens is misshaped, okay? So then it goes on, the directions say this condition can also be corrected with properly formatted lenses. Place the corrected lens +175 in the front slot, and notice the effect of rotating. So this is where the eye doctor really has to do the 1, 2, 3, 4, etc. Now watch this. Hopefully I don't get it right on the right spot, but watch my star. It's blurry, but now I'm going to twist this around. Oh, is it getting better?
Yes,
yeah, about right there. Again, now everything's all lined up correctly. Everything's perfect. But if I keep going, oh, did it get blurry again? Yeah, so this is where the eye doctor has to, you do the precise measurements and find everything exactly to get that best fit and all the measurements, all the different, everything to line up correctly. So that's what's going on with astigmatism, okay? Now, let's do one more. Removal of the lens. So this is where some individuals actually have their lens removed, and that's called cataract surgery. Even without a lens, vision is still possible with corrective lenses. It says remove all the lenses from previously. So we're going to remove the ones that we were using previously, because get back to a normal eye. Am I back to a normal eye? Do I have a nice star? Yeah, that's back to the normal eye. It says, and also remove this positive 20. This lens always stays in your eye. Do you always have a lens in your eye? Let's see this picture right here in my book. Do we always have a lens in our eye? Yes, we always have a lens in our eye, unless you have cataract surgery. So I'm going to remove this. And what happened to my star? It's not there anymore, okay? So again, when somebody has cataract surgery, this is where the lens becomes cloudy and proteins build up, etc. And it's fairly common in older individuals, but I've actually had some students in the past that have actually had to have the cataract surgery and have the cataract removed and have removed the whole lens and have an artificial one placed in, okay? So that's obviously can be common in some cases. So anyway, it says attempt to focus the image closer to the eye and place the corrective lens +7. Let me find the +7. So like I said, some individuals can actually wear the big thick glasses, and this can fix the problem. And so right now when I move this closer, the star is still blurry. Do you see the star? It's still blurry, but it says to put big old thick glasses on, +7, and when we move closer, and again, this is where a lot of individuals that, are older and they can't see and they decide to not have an artificial lens put in and they just want to wear the big glasses, they can. But they have to get really close, and they usually have to have fairly thick glasses. And can you somewhat see the star now, or is everything extremely big?
Yes, extremely big.
Extremely big, yeah. So again, that's how cataracts work if you do not have an artificial one placed in. Now, give me one sec. I actually have an artificial, sorry. I actually have an artificial lens at home. I have to apologize, guys. I actually do have an artificial lens at home. And if anybody wants to see it, send me an email and I'll post a picture of it. Again, I forgot to bring it with me today to actually show it to you guys. But it's literally a lens like this, but it's extremely small. I mean, it's to the point where I have to, it's like the size of an eraser head. That's like the diameter of it, just to give you an idea. And again, that's an artificial one that somebody would have surgically implanted if they have something wrong with their normal one, okay? So that's where individuals have cataract surgery and get an artificial one put in. All right, so that's all you need for this part with the Ingersoll eye model. The next part, guys, we're gonna do is actually the visual acuity. And this is where we're gonna see whether or not you have 20/20 vision, okay? So this is this model right here, or this paper right here. So most of us, as long as we have good eyesight, have 20/20 vision, meaning that at 20 feet away, you can read this line right here, PHUNTDZ, okay? And again, it's kind of like font size. That's how I think of it, like font size 20, like if you're typing a paper, you can read font size 20. If you're up here, we're at 20 feet away, and you can read font size 200, and that's the only thing you can read is the big E, you're considered legally blind, okay? So anyway, you should be able to read this one right here. And if you can read the smallest one, 2015, that means at 20 feet away, font size 15, you can read at 20 feet away. You have really good eyesight. Now, just to give you guys another idea, if I was a hawk or an eagle, soaring above in the sky, and I'm looking for my lunch and I see a snake or a mouse, I can see it. Guess what? A lot of predatory birds like that, they actually have 20/2 eyesight. They could read like font size 2. So just to get you guys thinking about this, I marked off where 20 feet is actually at, right here, and I'm going to take my glasses off, and this is 20 feet away. This is where the whole 20 over whatever number comes from, okay? So at 20 feet away, I'm going to try to read that bottom line with my glasses off, and guess what? I can't read none of them with either eye. I'm terrible. It's bad. I can maybe read a couple. P-H-N-U-N, no. So yeah, I got glasses, so I can't see them. Even with my glasses, I haven't had new glasses in about 2 years. I need to get in. So my right eye, I can read, let's see, P-H-U-N, I'm fogging them up, T-Z, did I get it right? I don't know. Okay. The other one, yeah, I need new glasses. Again, mine need to be adjusted. As you get older, your eyesight just goes downhill. And then I cannot read 20/15 at all. Okay. So that's what you guys do. You do one eye and then the other eye, and obviously you have to get the right curvature, and then hopefully you have 20/20. So that's how you figure out, you know, your actual vision. You know, what feet away, what size letters you can read. And like I said, if I was a predatory bird, I can read all the way down to font size 2. Isn't that crazy? Standing right here, 20 feet away. Now, the other part of today's lab, which you can tell on your worksheet, guys, that Mrs. Dust is actually 20 over, I could read 20/20. It was close. I would say I was 20/20 in my right eye and 20/30 in my left eye. How's that? So, again, just so you guys know, and make sure you guys got the right answers again for my right eye. And of course my pencil doesn't work. My right eye, I said I was 20/20 right, and then my left eye, I said I was
20/30.
it'd be 30/20. I said that wrong. No, my bad. 20/30. Yeah, it's the 20 feet away. I said that again. Thank you for correcting me on that. It's because it's always the 20 feet away. So my right eye is 20/20 and my left eye is 20/30. I need to get new glasses. So yeah, that's that part. And let's see. My next part is what I do with my directions. Over here. So we did that next part with the actual acuity chart, visual acuity, and again, make sure you read the directions. Next one is astigmatism. This is where you're going to stand 10 feet across, or 10 feet. So here's my 10 feet. And I'm going to look at the one with the spokes on it, next to the one we just used that looks like a wheel. And this is astigmatism chart. This is where you're going to take your glasses and contacts off. And this will show whether or not an individual has an astigmatism. And what you're looking for here, guys, to know if somebody has astigmatism is the lines, the 3 lines for each number will blur together. Like if I was looking at number 1 and all the lines blur together at number 1, that's where my astigmatism is at, okay? So in my case, I had my astigmatism corrected. I had LASIK surgery when I was younger, so I should not have astigmatism, and I do not. But let's go ahead and just write down for the answer that Mrs. Dust does not have astigmatism, but just so you guys know, again, that I don't. That's what you guys can put for your answer on your worksheet. Again, you guys are using my answers. Actually, I'm sorry, there's not actually a question on that one, but again, Mrs. Dust does not have a astigmatism, but all the lines would blur together. Like if it was number 1, they'd all blur together as one smudge. Again, that's what the whole point of astigmatism is. All right, so there's not a question for that one, okay? But again, it's still important to know. Then we have another activity. This is where you guys are going to find the diameter of your blind spot, okay? And this is where you guys are going to use these directions, okay? So make sure you read over the directions, okay? And what you're gonna do is I'm gonna sit right here. I'm gonna sit right here, and I am going to read your directions. I'm gonna keep the circle in my periphery. I'm gonna cover up my left eye, and I'm gonna focus on the addition signs, and I'm gonna wait until my that circle goes away, and then I'm gonna make a mark. Okay, so I'm gonna watch, and when that circle goes away in my periphery, then I'm gonna make a mark. Okay, it goes away about there. This darn pencil. And it reappeared about here, meaning that I could see the circle come back up. Okay, So what I'm gonna do is count the spaces in between here. 1, 2, 3, 4. So I got 4 spaces. I'm gonna take 4 multiplied by 0.28, okay? And when I do that, guys, again, now just so you guys know, the average diameter of the blind spot, it's on your worksheet, it tells you, is actually 1.5, okay, millimeters. So I should be close to that. So when I do the math here, guys, what do I get? Oh man, my pencil's just giving me fits today. Here we go. I multiplied that. My diameter, guys, of my blind spot is 1.12. And again, that's my blind spot, which is also called my optic disc. You'll read about that in the directions and in the notes, etc. But again, I would say I'm pretty average. 1.5 is average. I got 1.12, okay? So again, that's what you guys have to do. And actually, you can do your own. So I would like you guys to do your own for this little exercise, because this is directly out of your lab manual. So this would be for my right eye. Sorry, this would be for my right eye. You guys then would do the same thing for your left eye, okay? So again, I'll do it for my left eye too. Okay, so I'm covering up my right eye and I'm focusing on the crosses, as you guys can see. And there should be about a foot distance between you and the paper. And whenever it goes away, which in my case it went away there, repeat there, so they're different. I got 1, 2, 3, 4, 5, 6 spaces. So I take 0.28 multiplied by 6, okay? And that time I got 1.618, and that'd be my left. But I want you guys to do your own, okay? So that's how you do that particular little exercise, okay? So that's finding the diameter of the blind spot. Now there's one other little experiment that we need to do, and that's called accommodation, and that's your near point. And I will tell you guys that as you get older, guys, that's the ruler. Where's my ruler at? Okay. As you get older, just like every senses, guys, your senses and your abilities to perceive, etc., they just kind of go downhill. They get worse and worse, like your taste and your reaction time, etc. But so does sight. And that's why most of you, by the time you reach age 50, you need reading glasses. Again, I think they say, like, I don't know, I think it's like, don't quote me on this, please, but like 80–90% of people, by the time they reach 50 or so, they need reading glasses. So anyway, this gets you thinking about this. So this is your near point. So this has got little numbers and letters on it, as you guys can see, and then there's actually a ruler on here in centimeters. So what you're going to do is find how near you can see something for your age. Now, you guys are all fairly young, around 20 or so, so your near point should be right around 9 centimeters. I'm older, mine's going to be around 14, 15, okay? So let me show you how you're going to do this. What you're going to do is put the ruler up to your cheek and do one eye at a time. And you're going to start out here, and when the numbers and letters on here start to get blurry, that's your number you're going to look at on the ruler. So when they start getting blurry, mine got blurry about there, about 13, 14, give or take. That is my right eye. Now I'll do my left eye. That's centimeters. So I'm going to shut this eye, like so. About right there. Oh, that's not too bad. I got about 10 on that one. So again, not too bad. But again, as you get older, it gets worse, 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 worse. And that's why we all need reading glasses as we get older. So, in your case, what did I tell you guys? Again, this is what I want you guys to write down for Mrs. Dust's answers on the worksheet. Mrs. Dust had, for her right eye, what did I say? It was like 14, I think, 14 centimeters. And for the left eye, we'll say 10 centimeters. Okay, so make sure you guys have that. That way I know you guys took the time to get my answers and watch the video. And then, of course, the next question, it says, why does it get greater when you get older? Because, again, this question right here is actually in the reading. So you have to read over the reading, okay? All right, with that being said, that's the end of this lab. If you have any questions, please get a hold of me. Hopefully you enjoyed it. And if you have any questions, like I said, I'm just an email away. So talk to you guys later.